So the next one on your packet is 4.1b. So we are going to take a closer look at the quantum mechanical model. Again, it's going to help you better understand what we're doing in 4.1 with electronic configuration. So we went from the Bohr model, right, to the quantum mechanical model. So we are going to work on the quantum mechanical model in today's lesson. So the quantum mechanical model has four basic shapes or orbitals. These are probabilities where the electrons may be. So the S, that's the shape of the S. We've seen that when we're doing history of the atom. The P is bilobed, right? It has two lobes right there. Then the D is one orbital. As you can see, it has four lobes in one orbital. And then the F, we're not going to draw that. It's more complicated. It has eight lobes. Okay. So one orbital, remember, can take two electrons. And the P, there are three of them, the X, the Y, and the Z. And each one can take two electrons, so a total of six electrons. You can guess how many are there in the D. We've learned that in the previous lesson. There are five orbitals in the D. And each one can take two electrons, so a total of 10. For the F, there are seven orbitals. Each one can take two electrons and a total of 14. Hydrogen only has one electron, so it is found in the s orbital. Okay. Helium has two electrons, they will fit on the s orbital. That is why you see, if you write electronic configuration for hydrogen and helium, you realize that they all have the same type of orbital, which is the 1s. Okay. This also corresponds with the period on the periodic table. H and helium are the only elements in period 1, so you always start from the top left hand corner. So again, that is going to be a review of what you've done under the lesson for electronic configuration. When you start a new period, you start back on the SPD sequence all over again. Okay, so let's look at lithium and beryllium. They are elements number 3 and 4. Okay? Lithium has the S shell from period 1 inside the S shell from period 2. Okay. Beryllium also has the S shell from period 1 inside of the S shell from period 2. As you can see how they are arranged right here in this image. But two electrons on the S shell. So, but what do I do when I need to do or go to boron? Now we start filling up the p orbital. We start filling the p. There are three p orbitals, we've said that already, and that's their shape on the x-axis. So if you've done uh, a space, because this is space when we have three planes. So in math, two axes will give you a Cartesian plane. But by the time you have three axes, we start talking about space. Okay? Three axes will mean that we're in space. Two axes in math will mean that we're on a plane. Okay, so when you use the x and y axis in math, that's a plane. But with three axes in math, we're talking about space in this case. So because we define orbitals as a region of space, that's why you see three axes right there. On the x-axis, the orbital that sleeps on the x-axis is called the px. The orbital that sleeps on the y is called the py, while the orbital that sleeps on the z is called the pz. Each one has a dome shell shape and can take up to two electrons. Same thing, we have the D. Okay, carbon's electron will also be on the px. Each p orbital can hold all the way two electrons. So you can see how those electrons are actually arranged on those axes. So that's a quantum mechanical way of looking at the electrons. Okay. After nitrogen comes oxygen. Its electron is also on the py axis. That's how those electrons are arranged on the axis. Okay. So when you're done with period 2, you always go to period 3 and so on. So with period 3, we start with the s orbital that covers period 1 and period 2. Okay. So you go through these ones. That. So remember that when you're filling electrons and you reach the p, there are three types of p, but you always want to make sure that the pxp fills before the py, and when the py is done before you go to the pz. Okay. All right, so that's the end for the quantum mechanical model. Make sure you fill this section in uh, your packet.